July 14, 1944, 3 miles southwest of Saint-Lô-France. Lieutenant General Omar Bradley stood with his arms crossed watching a Sherman tank back away from a hedgerow that had stopped American advances for 6 weeks. Around him stood a small group of officers, including Major General Leonard Garrow, commander of 5th Corps, and several ordnance specialists who had been called to see what might be either a breakthrough or another failed experiment. Welded to the front of the tank were 4 steel prongs that jutted forward like tusks, a contraption so simple that Bradley had initially dismissed the report when it first came to his desk. But desperate times needed desperate actions, and the American breakout from Normandy hung in the woo balance. The tank's engine roared to life. The driver shifted into gear and drove directly at the old earth wall. 10 emp. 15. The steel prongs hit the hedgerow with a sound like tearing cloth, a noise that would become familiar to American tankers. Across France in the coming weeks, earth and roots burst up in a fountain of dirt. The tank did not climb or tilt. It drove straight through its prongs, cutting into the base of the hedgerow row like big knives through tough cloth. And then, in less than 5 seconds, the Sherman burst through to the other side, trailing broken branches and torn plants, but otherwise undamaged, its belly armor never exposed to enemy fire. Bradley's staff officers cheered. Ordnance specialists rushed to check the hedgerow row, measuring the breach, checking for damage to the tank. The general himself was quiet for a moment, his mind already figuring the implications. If this tool worked reliably, if it could be made in large, if it could be put on enough tanks before the planned attack, then maybe Operation Cobra could succeed. Perhaps the stalemate could be broken. He turned to Lieutenant Colonel John Madaris, his chief ordnance officer, and said words that would change the course of the war. "I want these devices made and fitted to as many tanks as possible. Every Sherman, every Stuart, every tank destroyer we can modify. I want them ready before Operation Cobra launches. Round-the-clock production. Use every ordnance unit, every maintenance depot, every welder we have. This is top priority." What Bradley had just seen was the answer to a problem that had almost turned the biggest sea invasion in history into a bloody deadlock. For 6 weeks, the Battle of Normandy had stopped the most powerful army ever made. The hedgerow's old field walls in Normandy had proven stronger than German bunkers, more dangerous than minefields, and deadlier than the Atlantic Wall itself. And the man who solved this hard problem was not a general with long experience, not an engineer from MIT with fancy degrees, but a 29-year-old sergeant from New Jersey who made a fix from scrap metal taken from German beach traps using only common sense and a welding torch. This is the story of how Curtis Coulin's simple welding idea broke the Normandy deadlock in 1 week and opened the road to Germany, 300 meters away. Supreme Commander Dwight David Eisenhower walked back and forth in his office at Southwick House near Portsmouth, studying maps that showed signs of growing trouble. It was mid-June 1944. The D-Day landings, done just days before, had worked better than anyone had hoped, even with the terrible losses on Omaha Beach, where American soldiers had almost been pushed back into the sea by the end of June 6th. More than 150,000 American, British, and Canadian troops had taken positions along 50 miles of French coast. Within a week, the Allies had landed over 300,000 soldiers and built a strong beachhead from the Cotentin Peninsula to Caen. The biggest sea attack in history had broken through Hitler's Atlantic Wall. The fortress Europe that Nazi leaders had called impossible to break had been entered. But the maps showed a worse picture. Yes, the landings had worked. The beaches were safe. Supplies were coming in through the two Mulberry artificial ports and straight over the beaches. But the push inland, the fast move that was meant to drive the Allied armies deep into France, had stopped almost at once. By mid-June, 2 weeks after D-Day, Allied forces held a beachhead only 20 miles deep and 50 miles wide. More than 1 million soldiers were now on shore, but they were trapped in a small coastal strip, unable to move forward, losing thousands each day, and facing the real chance that the whole invasion might turn into the same slow trench war that marked World War I. The grand plan made over 2 years called for a fast breakout. From the beachhead, British and Canadian troops were to take Caen, an important road and rail center on D-Day itself, and then move south into open tank country, was what planners had hoped for. American troops were supposed to sweep across the Cotentin Peninsula, take the port of Cherbourg in 9 days, then turn south toward Brittany. Within 2 weeks, the Allied advance was supposed to reach 15 miles inland, along a steady front, fast-moving battle tanks rolling deep into German lines. That was the dream that shaped the plan. But instead, the Allies were stuck in terrible close fighting, moving by yards instead of miles, losing thousands of men for tiny bits of land. And the reason had a name: the bocage, the hedges of Normandy. June 7th, 1944. Just 1 day after the landings on Omaha Beach, soldiers from the 1st Infantry Division, called the Big Red One, pushed inland from the coast. They were tired from the beach fight after taking nearly 2,000 losses, but they were alive and had broken through the Atlantic Wall. They thought they would meet Germans falling back, maybe some quick defenses in the small towns ahead. But what they found was a land that looked made to help defenders and kill attackers, a green maze deadlier than the forts they had just beaten. Private James Henderson from the 26th Infantry wrote in his diary that first day, words later found in the National Archives, "We thought we were through the worst after the beach. We had beaten the Atlantic Wall. We had lived through the worst that Hitler could send. Then we came to these hedges, these cursed Norman hedges. God help us. God help us all. These were not hedges, like Americans knew not, the neat bushes around home yards, not farm fences that could be cut or pushed down. They were old walls built for hundreds of years by Norman farmers who had shaped their land since the Middle Ages. It began about 1,000 years before, when farmers cleared stones from their fields and stacked them at the edges to mark land and keep animals in. Every new generation added more stone, more dirt. Seeds from the plants on top would fall, grow, and turn into thick brush and trees. After many centuries, these walls became high earth banks from 3 to 12 feet tall and 1 to 10 feet wide at the bottom. The soil making these banks was packed hard, like concrete pressed down over hundreds of years, and strengthened by the roots of trees and plants growing on top. On these earthen walls grew oak trees, hawthorn bushes, brambles, wild roses, and thorns, all tangled together into barriers that rose 15 feet above the ground. The roots went deep, some 10 to 15 feet down through the packed earth, making a structure stronger than most forts built by humans. The roots were so thick and twisted together after hundreds of years that the hedges could not be dug through without power tools and could not be blown apart without huge explosives that would warn every German nearby. These hedgerows surrounded fields that were all different sizes, but usually about 200 to 400 yards across. Some fields were almost square, some long and narrow, some triangular. The layout was completely irregular, made over 1,000 years by land laws, family inheritance, and farming practices. Photos taken from planes Before D-Day showed how big the problem really was, though intelligence officers did not see how serious it was. One photo of the American sector covering just 8 square miles near St. Lo showed almost 4,000 separate fields, each surrounded by hedges. Each field could be a fortress. Each hedge was a defensive wall, and there were thousands of them stretching across the whole American area, from the coast to the base of the Cotentin Peninsula and south towards St. Lo. For the German soldiers, each hedgerow was a ready-made fighting position better than anything military engineers could build. Machine gun teams could dig small firing holes into the earth just big enough for the gun barrel that overlooked the open fields. These positions could not be seen from far away and were protected from artillery by the thick earth. The plants on top hid them from planes flying overhead. From the air, the hedges looked like one solid green cover. The thick walls of dirt protected soldiers from shell fragments and small gunfire. A German soldier hiding behind a hedgerow was safer than a soldier behind a hedgerow was safer than one in a concrete pillbox, because a pillbox could be seen and targeted, while a hedgerow position stayed hidden until it opened fire. The advantages for defenders were huge. One small German squad of 8 or 9 men, well placed behind a hedgerow with a machine gun and rifles, could cover a whole field and hold off an American company of 200 men for hours. The Germans did not need long continuous lines or to man every hedgerow. They just put small groups all over the bocage, creating a defense in depth where each position helped the others. When American soldiers attacked across a field, they faced fire not just from the hedgerow in front, but also from hedgerows on the sides, making crossfire that turned every field into a killing zone. American attackers had problems almost impossible to solve with the tools and plans they had. Infantry crossing open fields were totally exposed. There was no cover in a Norman field. No trees, no rocks, no holes in the ground, just open grass or crops, with German machine guns and rifles covering every yard from positions that could not be seen until they fired. The Germans had already set their weapons on likely crossing spots, marking ranges, calculating angles, ready to fire. The moment American troops came out of one hedgerow, the path to the next was through pre-targeted killing zones where Germans did not need to aim. They just fired at the points they had planned. The sunken lanes that connected the fields worn down over centuries by carts were just as deadly. These narrow lanes, some only wide enough for one vehicle, were obvious routes for Americans and perfect spots for German ambushes. The Germans blocked lanes with fallen trees, rubble from carts, or piles of dirt. Then they put machine guns in hidden positions to cover the obstacles. American troops trying to clear these lanes were forced into narrow paths where one machine gun could stop a whole platoon. And American Sherman medium tanks that were supposed to be the key to fast mobile battle and quick attacks were stopped completely by the bocage. The Sherman was a good tank by any normal standard. Its 75mm gun could destroy any German tank at normal combat range. It was reliable, easy to fix, and made in numbers German factories could not match. American factories were building more than 1,000 Shermans every month. But all these strengths meant nothing in the bocage, because Sherman tanks could not break through the hedgerows. The earth banks were too thick, too solid. These banks were held together by thick roots. A Sherman's 75mm gun could tear the plants on top, but that did not make a big enough hole for the tank. The earth base stayed solid. Tank commanders tried to force their way through by backing up and then charging at the hedge to use the tank's weight and power. This was deadly. When a Sherman tried to climb a hedgerow, the front rose as it went up, and the tank tilted back at a 30 or 40-degree angle. This exposed the belly of the tank, the bottom between the tracks, which had only 1 inch of armor. That thin. Armor was only meant to stop mine fragments, not anti-tank weapons. A German soldier with a Panzerfaust, the shoulder-fired anti-tank rocket, given to many German infantry, could hide in the next field and wait. He would hear the tank engine roar, as the Sherman climbed. He would see the front rise above the plants, and when the belly was open, he would fire. 1 rocket was usually enough. The Panzerfaust could penetrate nearly 6 inches of armor against the Sherman's 1-inch belly plate. It was devastating. Lieutenant Colonel Wesley Yale, who led a tank battalion in the 2nd Armored Division, lost 4 Shermans in a single morning, trying to breach a hedge near the town of Isigny. 4 tanks destroyed 4 crews, killed or wounded 16. Men, dead or injured, and not a single successful breach. His after-action report, filed on June 15th, showed the frustration and rage felt by every American armor officer in Normandy. The enemy did not even need to see our tanks to destroy them. They put themselves in the next field behind the next hedgerow and simply waited. They listened for the sound of our engines. They heard us climbing the obstacle. And when we reached the top, when our belly was exposed, they fired. We were losing crews and machines to an enemy we never saw, never engaged, and never had a chance to fight. Our tanks, which should have been our greatest advantage, had become death traps in this cursed country. American forces tried every solution, their training and doctrine suggested combat engineers trained in demolitions and obstacle clearance were brought forward to blow gaps in the hedgerows using explosives. This technique worked technically. A properly placed charge of TNT or Composition C could blast a hole through. Even the thickest hedgerows could be cleared, using explosives, creating a hole big enough for a Sherman tank to get through. But this method had deadly problems. First, it was slow. Engineers had to move forward, under fire, reach the bee, hedge place the charges, hook up the detonators, back away to a safe distance, and then set off the explosion. This took 10 to 15 minutes in perfect conditions and even longer under enemy fire. Second, the blasts told every German nearby what Americans were doing, and in the quiet Normandy countryside, that meant every German within 2 or 3 miles, enemy machine gunners and mortar crews would aim at the gap before the smoke even cleared 3rd American soldiers and tanks moving through. The holes were funneled into a narrow path that became a pre-targeted killing zone. Germans did not need to find targets. They just shot at the gap and hit whatever came. Specialized armored vehicles like bulldozer tanks were only a little better. These were normal Sherman tanks with big steel bulldozer blades on the front, made to clear obstacles on beaches during landings. In theory, they could push through or scrape aside hedgerows, making a path for other tanks. In practice, they were prime targets for German anti-tank gunners. Bulldozer tanks were slower than normal. Shermans harder to move and easy to see. German spotters would see them right away and fire, knowing that taking out the bulldozers stopped Americans from clearing obstacles. The 75th Armored Division that landed in Normandy with 14 bulldozer tanks lost 11 in the first 3 weeks. By early July, American forces had almost no bulldozer tanks left, and the few left were saved for key missions, not normal hedge clearing. By late June 1944, 6 weeks after D-Day, the American advance had slowed to a terrible crawl measured in yards per hour, not miles. The human cost was huge and could not be sustained. Official U.S. Army histories show that the 8th Corps, moving through the bocage, toward Le Hay du Puys and Lalande suffered over 10,000 casualties while advancing about 7 miles. Some secondary. Some sources said that for parts of this advance, as many as 1,000 soldiers were killed per kilometer. While the exact numbers are hard to check from official records, it is clear that American infantry was dying at rates as bad as or worse than the worst battles of World War I. Taking Moncastre, a hill overlooking the Cotentin Peninsula, cost about 2,000 American casualties in brutal close fighting. The 1st Infantry Division that landed on Omaha Beach on D-Day lost 75% of its frontline infantry in the first month. Companies that started with 150 men were down to 30 or 40. The 29th Division suffered the same terrible losses. This was not fast mobile warfare. This was not the rapid advance Allied planners had hoped for. This was grinding combat, where every field had to be fought for every hedge attacked, every few hundred yards gained with American blood. And America, even with all its factories and men, could not keep up these losses. The replacement system was already stretched, new soldiers arriving. In Normandy, were thrown into combat with little training put into veteran units to fill gaps left by the dead and wounded morale that had been high after D-Day was falling fast. Soldiers who had survived the beach thought they had faced the worst, but were being broken by the hard-hedge fighting General Omar Nelson Bradley. Commander of the 1st U.S. Army, faced a crisis that threatened not only his own reputation, but the entire plan for invading Europe. His troops were exhausted, discouraged, and losing irreplaceable infantry at rates that could not continue. British and Canadian forces to the east fighting around the city of Caen were making just as little progress against strong German armor Field Marshal Montgomery's plan to take. Caen on D-Day had completely failed. The city would not fall until mid-July, more than a month late. The grand plan that had guided 2 years of planning the dream of a fast breakout and mobile warfare across France was collapsing into the same slow trench warfare that had marked the Western Front in World War I. Bradley's Chief of Staff, Major General Walter Bedell Smith, who was also Eisenhower's Chief of Staff at Supreme Headquarters, described the situation clearly in the South. Of Normandy, he wrote to Eisenhower, "Every small field is a fortress. Every hedge, a German strong point. We are fighting World War I again, but this time the trenches are green and growing. Our advantages in mobility, armor, and firepower are stopped. By the land, the Germans were trading land for American lives, and they were winning that trade. The German defense of Normandy was smart in its simplicity and very effective. Instead of trying to hold a long continuous line, which would have needed more soldiers than they had, German commanders put small groups of infantry all over the bocage, using the natural hedgerows to make a defense in depth that was almost impossible to beat with normal tactics. A typical German position in the bocage had 2 or 3 machine gun teams, a mortar crew, and a few riflemen, maybe 20 to 30 soldiers. These small groups took positions across 3 or 4 hedgerows, creating interlocking fields of fire and supporting each other. When American soldiers attacked, the Germans waited until the Americans were fully exposed, crossing open fields. Then they opened fire with deadly effect. German machine guns, especially the MG-42, which could fire 1,200 rounds a minute, could wipe out entire American platoon in seconds. The Americans would take cover call for artillery and try to find the German positions. But by the time artillery hit, the Germans had already moved to their next positions in another hedge, leaving Americans to attack empty spots while German fire came from a new direction. German tactics used every advantage the land gave them. Machine gunners dug their firing positions deep into the hedgerows, making small tunnels or caves that protected them from artillery and hid them completely from view. The gun opening was just big enough for the barrel, about 6 inches wide and camouflaged with cut plants, so it could not be seen from more than a few feet away. A German gunner could sit safely protected from everything except a direct hit and fire on American soldiers in the open German snipers. Used the height from trees growing on top of hedges to watch American movements and target officers and sergeants. Losing small unit leaders hurt American forces badly. A rifle company that lost its experienced sergeants and lieutenants in the first days would be much less effective even with new officers, because the replacements did not know the men or who to trust in combat. German snipers knew this and aimed for anyone giving orders or carrying maps and radios. The Germans camouflaged their positions very carefully. They cut fresh branches every morning to replace dying ones. They covered the tracks left by their vehicles. Sometimes they even went so far as to try to make flattened grass stand upright again. They dug tunnels under hedgerows to make protected routes for moving between defensive positions, letting them move without being seen by American fire. Some German units dug complex trench systems linking several hedges, making underground networks that let entire squads move from place to place without ever being visible to American soldiers or spotter planes. The psychological effect of this fighting on American troops was severe and built up over time. Men who survived the horrors of Omaha Beach, who faced German machine guns and artillery during the landings, who thought they had seen the worst combat imaginable, found the bocage even more frightening. On the beach, at least the enemy was visible. You could see the German bunkers. You could identify targets. You knew where the fire came from. In the hedgerows, death came unseen from positions that could not be found until they opened fire. Every field could be a killing ground. Every advance across open ground was a journey into terror, waiting for German machine guns to cut you down before you could react. Captain Joseph Ewing of the 175th Infantry Regiment in the 29th Division described approaching St. Lo in words that showed the suffocating claustrophobia of hedgerow combat. He later wrote, "After the war, we advanced through a huge maze of natural fortifications miles deep. Every hedgerow was a possible enemy position. Every field crossing could be fatal. We could not see more than one field ahead. We had no way of knowing where the Germans were until they fired." The tension, the constant fear that at any moment machine guns might fire from hidden spots, wore men down faster than actual fighting veterans, became hollow-eyed and shaking. New replacements broke under the stress. Within days, into this desperate situation, where the whole Normandy campaign was on the edge of failure, where American casualties rose by the thousands, and no solution seemed possible, came an ordinary soldier with an extraordinary idea, Curtis. Grub Culin III was 29 years old in the summer of 1944. A sergeant was serving with the 102nd Cavalry Reconnaissance Squadron, part of the 102nd Cavalry Group under 5th Corps. He was nobody special in the huge American Army. He had no advanced degrees, no engineering training. His background was completely ordinary. The kind of American story repeated millions of times. Across the armed forces, Culin was from Cranford, New Jersey, a small town about 15 miles west of New York City. His father worked as a salesman for a liquor distributor. Curtis went to local public schools and graduated from Cleveland High School in Cranford in 1935. Before the war, he worked as a sales promotion assistant for Schenley Industries, the same liquor company his father worked for. When the war started, he enlisted in the New Jersey National Guard and was mobilized with his unit. He was trained as a tanker and driver. He knew how to maintain and operate a Sherman tank. He knew how to fight in armored combat, but he had no special technical skills that would hint he could solve a problem that had baffled the best minds. In the American military, what Curtis Culin had was something no school could teach or training could give. He had practical American ingenuity, a problem-solving skill learned growing up during the Great Depression, when money was tight and you had to fix things yourself. He could make do with whatever materials were at hand and improvise solutions instead of waiting for someone else to fix the problem. This was a very American trait, from a culture that valued initiative and practical results over formal credentials and theory. It was the same spirit that had driven American inventors for generations, from Benjamin Franklin experimenting with electricity to the Wright brothers building a plane in a bicycle shop in early July 1944. During a short break from fighting, soldiers from Culin's unit gathered informally to talk about the hedgerow problem. This was not an official meeting. It was just soldiers talking, sharing frustrations, venting anger about their situation. Tank crews, infantry, and officers all joined. The conversation, they talked about friends killed or wounded, tanks destroyed trying to breach hedgerows. They shared ideas, most of them impractical or impossible. At some point, a soldier from Tennessee made a suggestion that sounded like a joke. Or maybe the ramblings of a man half crazy from combat stress. Military historian Max Hastings, in his book Overlord D-Day and the Battle for Normandy, published in 1984, identifies this soldier only as a Tennessee hillbilly named Roberts Hastings. Gives no first name, no rank, no unit, and no documentation. Despite extensive research by military historians in the decades since, have found no primary source that proves this man's identity or even confirms he existed. The story depends entirely on Hastings's single mention, possibly based on oral history or unverified anecdotal information. Still, according to Hastings, this soldier said something like, "Why don't we get some saw teeth and put them on the front of the tank and cut through these hedges?" Most of the soldiers listening laughed or dismissed the idea right away. It sounded ridiculous. Saw teeth on a tank, like some kind of cartoon monster. But Curtis Culin, sitting quietly in the group, did not laugh. He heard something in the suggestion that others missed. He saw that under the crude words was a mechanically sound idea. If tanks could not climb over hedges without exposing their weak undersides, and if they could not smash through the solid earth banks by brute force, then maybe they could cut through them. Use the tank's own weight and power to drive steel blades through the base of the hedge, severing roots and cutting earth like a plow through tough soil. Culin began thinking about the problem carefully. He imagined steel prongs or tusks sticking forward from the tank's hull. These prongs had to be angled slightly downward, so that when the tank drove into a hedgerow, they would bite into the earth at ground level instead of riding up the front of the obstacle. As the tank moved forward at full power, the prongs would cut roots and earth, while the tank's weight kept it level and stopped the dangerous upward tilt that exposed the belly armor. The cut vegetation and earth would be pushed up and over the tank, but the tank itself would drive straight through the breach at ground level. The idea was simple, smart, and possible with the technology they had, but it needed the right materials. The prongs had to be strong enough to cut through centuries of packed earth and dense roots. They had to be heavy enough to stay in place under stress, but not so heavy that they overloaded the tank. Suspension, or slowed it down. They had to be made of high-quality steel that would not bend or break while cutting through a hedgerow. But where could such materials be found in Normandy in July 1944? The answer was right there on the beaches where the invasion had happened 6 weeks earlier before D-Day. German engineers had put thousands of obstacles along the Normandy coast, making a barrier system meant to destroy Allied landing craft before they reached shore. One of the most common obstacles was called a Czech hedgehog, named because it looked like the anti-tank devices the Czech army had made before the war. Each hedgehog was made from 3 steel I-beams, strong industrial steel, about 6 feet long, welded together at angles to make a 6-pointed shape like a giant jack from a children's game. These hedgehogs were supposed to rip open landing craft or hold mines in place. In reality, the invasion had bypassed or destroyed most of them. Thousands of Czech hedgehogs now lay scattered along the beaches. They had been pushed aside by the landing forces, blown up by combat engineers, or simply avoided. The steel beams were still intact, and very strong, and were being collected in salvage yards behind the beaches, waiting to be sent back to England for recycling. This was exactly what Culin needed. High-quality steel already cut to useful lengths and available in large quantities. All he needed was permission to experiment and welding equipment. Getting approval from his immediate superiors was surprisingly easy. Officers at every level of the American Army in Normandy were desperate for a solution to the hedgerow problem. When Curtis Culin showed his company commander rough sketches and explained his idea, including where he would get the materials, the captain approved immediately. Within 48 hours, Culin had access to a Sherman tank for experiments welding, equipment from the unit maintenance section, and permission to organize a work party to get steel beams from a salvage yard near Omaha Beach. The prototype took 3 days to build. In early July 1944, Culin and his team picked 4 sections of steel I-beam from the salvage yard, each about 5 feet long and weighing roughly 100 pounds. They used cutting torches to bevel the front ends of the beams, making angled cutting edges that would dig into earth and roots better than blunt ends. They welded a horizontal crossbar to hold the 4. They positioned the prongs, carefully spacing them evenly across the front width of the tank. Then they welded the whole assembly, prongs and crossbar, to the lower front armor plate of the Sherman, making sure the prongs pointed forward and angled slightly downward. The result was crude, but it worked. 4 steel tusks stuck out from the tank's hull, angled downward about 10 degrees, ready to drive into a hedgerow. The assembly added around 400 pounds to the tank's weight. Not enough to affect performance much, but enough to notice the prongs extended about 4 feet in front of the tank's normal profile, so drivers had to be careful in close quarters. But if it worked, these small inconveniences would be worth it. The first test happened on July 11, 1944, in a field near the town of Issy-sur-Mer, several miles inland from Omaha Beach. About 20 soldiers, mostly tankers and officers from Culin's unit, came to watch. Most expected another failure. They had seen too many ideas for the hedgerow problem fail. A tank with steel prongs on the front seemed unlikely to work, where explosives and bulldozers had failed. But they wanted to see it, at least, to say they had been there when another crazy idea fell apart. The test hedgerow was picked carefully. It had to represent a typical Norman bocage, not a small or weak example that could give false results. The hedge they chose was about 4 feet, high at the earth base, topped with 15 feet of mature vegetation, including oak trees with trunks 4 or 5 inches in diameter. This was an average hedgerow, the kind American tankers saw dozens of times a day. If Culin's device could breach this obstacle, it could breach most hedgerows in Normandy. The Sherman tank backed up to get room to build speed. The driver, a corporal from Pennsylvania, whose name is not preserved in historical records, was nervous. If the device failed, if the tank got stuck like so many before he and his crew could be the next casualties. But he trusted Sergeant Culin, who had explained the theory carefully and seemed confident. The driver shifted into gear, pushed the throttle, and aimed straight at the hedgerow. 5 miles per hour, 8:10. The tank hit the hedgerow with the prongs leading. There was a sound like heavy canvas, ripping a deep tearing noise as steel cut through earth and roots. The prongs sank into the earth bank and penetrated deep. For a moment it seemed the tank might stall, might be stopped by the obstacle. Then the engine roar grew louder. The driver pushed full throttle. The tank's treads gripped the ground and pushed forward. Earth fountained up and over the tank's hull. Thrown by the force of the breach, branches snapped, tree trunks splintered. Vegetation rained down on the turret and rear deck. And then, in less than 5 seconds after hitting the hedge, the Sherman burst through to the other side, trailing broken branches and torn roots, but otherwise completely undamaged. The tank had not climbed the obstacle. It had cut through at ground level, just as culin had predicted. The soldiers watching erupted in cheers and shouts. Some cried not from sadness, but from relief and hope. For 6 weeks, they had watched friends die, trying to breach these obstacles. For 6 weeks, they had felt helpless against terrain that seemed impossible. Now, suddenly, almost unbelievably, a simple device made from scrap metal had solved the problem. Tankers surrounded culin, shaking his hand, pounding his back, thanking him with excitement that embarrassed the modest sergeant officers who had seen the test, were already thinking about the possibilities. If it worked once, it could work again. If one tank could be modified, all tanks could be modified. If the device was as simple and fast to make as it seemed, then maybe the entire American armored force could be equipped before the planned offensive. But one successful test, no matter how dramatic, was not enough to change a military campaign. The device needed repeated trials in different conditions. More tests were done over the next 2 days. Different hedgerows, different approach angles, different speeds. Every test worked. The device was reliable, predictable, and safe. Tank crews quickly learned the best technique. Approach at 10 to 12 miles per hour. Aim straight at the hedge. Give full throttle. At impact, the tank would shake as the prongs bit into the earth, but drive straight through without climbing or exposing the belly. Breaching time averaged 5 to 8 seconds from impact to emerging on the far side. Word of culin's invention spread fast through the 2nd Armored Division and beyond. Within 3 days of the first successful test, Major General Edward Brooks, commander of the 2nd Armored Division, had seen the reports and requested a formal demonstration. Brooks was a smart and aggressive commander who understood armor tactics and recognized a breakthrough when he saw one he immediately understood. The importance of culin's device and knew it had to be shown to the one man whose approval could authorize mass production and division-wide use. On July 13th, General Brooks sent a message to 1st Army Headquarters, asked Lieutenant General Omar Bradley to visit the 2nd Armored Division area for a demo of a new hedgerow breaching device Bradley buried under reports and complaints about the stalled offensive was at first doubtful. He had seen proposed fixes before, and they had all failed. But Brooks said this was different, and Bradley trusted his division commanders. He agreed to visit the next day. July 14, 1944, which is the demonstration that opened this story. Bradley arrived with his group, including Major General Leonard, Hedgerow of 5th Corps, and several ordnance specialists. 2 tanks had been prepared for the demo, a light M5A1 Stuart and a medium Sherman, both fitted with culin's device. The hedgerow chosen for the demo was picked to show typical bocage terrain, a 5-foot earth bank topped with thick brush and big trees, the same kind of obstacle that had stopped American advances for 6 weeks. Bradley and his officers took positions where they could watch safely. The light tank went first, backing up, to gain speed, then driving straight at the hedge. The impact, the sound of tearing earth and breaking roots. the fountain of dirt flying up, and then the tank bursting through in less than 5 seconds, happened before anyone could react. Then, the IB died. Sherman did the same thing with even more drama. Its extra weight and power pushed through the obstacle like it was soft clay. Not an earth wall built over centuries with tree roots. Bradley stood quiet for a moment, his mind racing over what this meant. 6 weeks of stalemate, thousands of casualties, an offensive about to start that could fail if tanks could not move through the bocage. And here in 2 minutes, the solution had been shown. Simple, reliable, and possible with materials on hand. He turned to his ordnance chief and gave the orders that would change everything. The talk after the demo lasted less than 10 minutes, but it set in motion a manufacturing effort done faster and bigger than anything seen before. Bradley wanted these devices on as many tanks as possible before Operation Cobra began. The offensive was set to start in 11 days on July 25th. That meant 11 days to make hundreds of devices, move them to units across Normandy, and weld them on tanks. It meant round-the-clock production. It meant using every ordnance unit, every maintenance depot, every welder in the American sector. It meant creating a mass production system for a device invented less than a week earlier. Lieutenant Colonel John Madaris, 1st Army Ordnance Officer, was given personal responsibility for the manufacturing program. He was a West Point grad class of 1930, a professional officer with wide experience in logistics and materiel. He saw at once that this was no routine job. This was an emergency crash program that might decide the whole Normandy campaign. Madaris returned to his headquarters and within hours had issued orders that would start the fastest military production program of the war. Every ordnance company, maintenance battalion, and repair depot in the American sector got orders on July 14th to start making hedgerow cutting devices. Right away, specifications were sent by phone and radio. 4 steel prongs about 5 ft long made from German beech obstacle steel, beveled cutting edges on the front ends, crossbar to hold prongs in place, whole assembly welded to the lower front hull of the tank. Simple enough for any good welder to make, hard enough that it needed skill and care to make sure the welds would hold under combat stress. Raw material was everywhere. Salvage yards behind the beaches had thousands of tons of steel from destroyed German obstacles. Trucks started hauling steel beams to ordnance units. Across Normandy, beams arrived in bundles, still rusty, and with barnacles from being underwater, some still damaged from explosives or shellfire. Ordnance troops sorted the beams, picking straight, undamaged ones and rejecting any with cracks or bad. Corrosion-selected beams were cut to length with acetylene torches, beveled on the ends and set aside for welding. Welding work was brutal. Summer heat in Normandy in July 1944 reached the 80s and 90s. Fahrenheit welders worked in heavy leather protective gear with face shields and gloves. Handling steel beams over 100 lb work was outdoors or in canvas shelters because there was no time for proper workshops. Each device took hours to weld. 4 prongs had to be welded to the crossbar welded to the tank hull. Every weld had to be strong enough to take the huge force when the tank drove into a hedge at full speed. A weak weld could fail at impact, possibly causing the tank to belly up on the obstacle, just like unmodified tanks. Did ordnance units worked in shifts, 24 hours a day? Welders worked 6-hour shifts, then rested, while other crews took over acetylene tanks and welding rods had to be brought in all the time. When one company ran low, trucks moved supplies from units that had extra. The whole system worked with the flexible improvisation that made American logistics strong. There were no detailed plans, no careful production schedules, only the urgent need to make as many devices as possible before operation. Cobra started tank crews from combat units, drove their vehicles to the nearest ordnance facility, waited while the device was made and installed, then drove back to their units. Some crews waited 6 or 8 hours. Others waited overnight. But they waited because they knew the device could save their lives. Tankers who had lost friends to panzer fire, when tanks bellied up on hedge, understood that Sikin's device could prevent those deaths. They were willing to wait as long as needed to get their tanks modified. Modified tanks began appearing in combat units in mid-July. At first, there were just a few. A handful per battalion. Crews with modified tanks would volunteer for the most dangerous missions, testing the devices under actual combat conditions. The reports that came back were all positive. The devices worked exactly as demonstrated. Tanks could breach hedge in seconds without exposing their weak undersides. Tank commanders could choose their own routes through the bocage, rather than being forced to follow roads or search for gaps that might be covered by German fire. The tactical flexibility was transformative. By July 20th, 5 days before Operation Cobra, was to begin, about 300 tanks in First Army had been fitted with Coulin's device. This was about 15% of American armor in the theater. It was not enough. Bradley wanted more. Madaris pushed production harder. More ordnance units were pulled from other tasks. More welders were pulled from maintenance work and set to making. Hedgerow cutters. The pace became frantic, desperate, driven by knowing that Operation Cobra was near, and every tank without a device was a tank that might be stopped by the bocage. By July 24th, the day before, Operation Cobra started. About 500 devices had been made and installed on American tanks. This was nearly 60% of the Sherman medium tanks, Stuart light tanks, and M10 tank destroyers taking part in the offensive. It was not 100%. There had not been enough time, but it was enough to give American armor the mobility it needed, enough to restore tactical flexibility, enough to break the stalemate. The tanks looked fearsome with their new gear. 4 steel prongs sticking from each hull gave the Shermans a fierce, almost predatory look. Soldiers began calling them rhino tanks, after the horned African animals. Others called them rhinoceros tanks. The names stuck. Within days, everyone in the American Army knew what a rhino tank was. British forces, seeing the American modification and its value, quickly made their own version. British ordnance units called their devices prongs and began making them from German beach obstacles, just like the Americans. By August, British prongs were being put on Sherman tanks in the British sector, though British production never reached the scale of the American effort. Germans, seeing rhino tanks in combat for the first time during Operation Cobra, had no official name for them. German after-action reports and prisoner interrogations called them American Hedger tanks, tanks with steel horns, or simply the modified Shermans. What is clear from German accounts is that the appearance of these devices was a nasty surprise. German defensive tactics in the bocage had relied heavily on assuming that American tanks could not move effectively through hedgerow country. When that assumption proved false, German defenses collapsed far faster than they might have otherwise. The final days before Operation Cobra were filled with frantic preparation. Infantry units practiced assault techniques. Artillery officers registered their guns on pre-planned targets. Air Force liaison officers coordinated with ground units to make sure close air support would be available. And throughout the American sector, hundreds of Sherman tanks with newly welded steel prongs conducted final tests, training crews in hedger breaching techniques, making sure that when the offensive began, armor could exploit any breakthrough achieved by infantry. And air power, July 25, 1944, Aero 940 hours. The sky over Normandy filled with the sound of approaching aircraft. More than 1,500 B-17 Flying Fortress and B-24 Liberator. Heavy bombers flying in formations so large they darkened. The sky approached there. Targets in a rectangular area northwest of St. Lo. The bombers had taken off from bases in England hours earlier, climbing to altitude over the English Channel, forming up into their massive formations, then flying south across the invasion beaches, toward their assigned target zones. The target area for the carpet bombing was a rectangle about 5 kilometers long and 1.5 miles wide between the towns of Montreuil and Hebra. This was the sector held by German forces directly in the path of the planned American offensive. The bombing was meant to obliterate German defenses, destroy command and control, networks, kill or stun German soldiers, and create chaos to let American ground forces penetrate deep into German rear areas before effective resistance could be organized. The bombardment began exactly at 0940. The first bomber wings dropped their loads from altitude. High explosive bombs and fragmentation bombs fell in a deadly rain. The effect on the ground was apocalyptic. Bombs weighing 500 dotted 1,000 AULLB, even 2,000 hours, will be detonated in rapid succession. The earth heaved and shook. Trees were blown to splinters. Hedgerows were obliterated. Buildings collapsed. German soldiers caught in the open or in inadequate shelters were killed instantly by blast, or shredded by flying fragments. Those who survived the initial explosions were stunned, deafened, unable to think or function. The bombing continued for nearly 1 hour. Wave after wave of heavy bombers passed over the target area, each plane releasing its bombs, then turning for the flight back to England. Following the heavy bombers came about 1 Euro-0 medium bombers and fighter bombers carrying incendiary bombs and additional high explosives. By the time the last aircraft departed, about 300 tons of high explosive bombs and 60,000 incendiary bombs had been dropped on the target area. The bombardment covered 12 square kilometers with about 5 bombs per square kilometer. The landscape was transformed into a ruined moonscape of overlapping craters, splintered trees, and burning debris. But the precision that bombarders had hoped for proved impossible to achieve. The target area was close to American front lines, separated in some places by only a few hundred yards. Thick clouds obscured visibility. Bomb aiming was done by dead reckoning and radar, both imprecise methods under the best circumstances. Some bombs fell short of the target zone landing, instead on American positions. The results were tragic. 111 American soldiers were killed and nearly 500 wounded by bombs from their own aircraft. Among the dead was Lieutenant General Leslie James McNair, who had been observing the bombardment from a forward position with troops of the 30th Infantry Division. McNair was the highest-ranking American officer killed in combat in the European theater during World War II. He held the rank of Lieutenant General at the time of his death, though he would receive posthumous promotion to full general. His death was a severe blow to American morale and a stark reminder of the risks of close air support, the friendly fire casualties. On July 25th, added to casualties from a similar incident the previous day when initial bombing runs had been aborted due to weather, but not before some aircraft had already released their bombs, killing and wounding over 150 Americans. The total friendly fire casualties from the Operation Cobra bombardment exceeded 800 killed and wounded. Despite these tragic losses, the bombardment achieved its primary objective. German defenses in the target area were effectively destroyed. The Panzer Lehr Division, one of the elite German armored formations defending the sector, was reduced to a remnant of its former strength. Its commander, General Fritz Bioline, later described the scene in terms that captured the sheer overwhelming violence. Of the bombardment, I observed a puff of dust with fountains of earth spewing high in the air. My front lines looked like a landscape on the moon, and at least 70% of my troops were out of action, dead wounded, crazed, or numb. About 0 German soldiers were killed in the bombardment. Dozens of command posts were destroyed, obliterating the command and control network that coordinated German defenses. Communications were cut. Telephone lines were severed by explosions. Radio antennas were knocked down. Officers attempting to give orders found themselves unable to communicate with subordinate units. Survivors of the bombardment emerged from their shelters, stunned, deafened, many of them suffering from concussion and shock. German defensive positions that had withstood weeks of American attacks were obliterated in less than an hour. Into this chaos, American ground forces advanced. The 7th Corps, commanded by Major General J. Lorton Collins, formed the main thrust of Operation Cobra. Collins was one of the most aggressive and competent corps commanders in the American Army, a man who understood the importance of maintaining momentum and exploiting success. His nickname was Lightning Joe, earned during fighting in the Pacific, and it reflected his tactical philosophy of speed and violence of action. 3 infantry divisions formed the assault force for 7th Corps, the 4th Infantry Division on the right flank, the 9th Infantry Division in the center, the 30th Infantry Division on the left. These divisions had been fighting in Normandy since D-Day. They were experienced, battle-hardened, and grimly determined. Their mission was to attack south from positions near St. Lo, penetrate German defenses shattered by the bombardment, and open a corridor through which American armor could exploit. Behind the infantry divisions waited 2 armored divisions. The 2nd Armored Division, the Hell on Wheels Division, was commanded by Major General Edward Brooks. The 3rd Armored Division, the Spearhead Division, was commanded by Major General Leroy Watson. These divisions contained the bulk of American armor that would participate in Operation Cobra, and a substantial portion of their Sherman tanks, approximately 60%, were now equipped with Curtis Coulin's hedgerow cutting devices. The infantry assault began in the early afternoon of July 25th, several hours after the bombing ended. American troops advanced through the devastated landscape, moving cautiously, at first expecting German resistance to materialize at any moment. But the resistance was disorganized and weak. German soldiers who had survived the bombardment were in no condition to mount effective defense. Many were still stunned, sitting in bomb craters, unable to comprehend what had happened. Others attempted to resist, but found their weapons buried under rubble or their ammunition expended. Command and control had broken down completely. German officers attempting to organize defense found themselves unable to communicate with higher headquarters or coordinate with adjacent units. The initial advance on July 25th penetrated approximately 1 mile beyond the start line. This was slower than hoped, evidence that even the massive bombardment had not completely eliminated German resistance. Hedgerows, even when damaged by bombing, still provided some defensive value. American infantry still had to clear German positions field by field in brutal close quarters combat, but the resistance was not the organized, coordinated defense that had stopped previous American attacks. This was the fighting of scattered survivors, individual acts of courage or desperation, rather than systematic defense in depth. Major General Collins, monitoring the advance from his forward command post, recognized something that others might have missed. The German resistance, though still deadly, was not coherent. There was no defensive plan being executed, no coordinated counterattacks, no systematic attempt to establish new defensive positions. The German command structure had been destroyed by the bombardment. Units were fighting in isolation, without support, without direction. The German front line was not bending under American pressure, it was breaking. Late in the afternoon of July 25th, Collins made the bold decision that would transform Operation Cobra from a limited offensive into a breakthrough that changed the entire Normandy campaign. He ordered his two armored divisions to begin their exploitation immediately ahead of the original schedule. The plan had called for infantry to open a wide corridor before armor advanced, but Collins saw that waiting might allow the Germans time to recover, to establish new defensive positions to bring up reinforcements. He decided to commit his armor, while the Germans were still reeling from the bombardment, gambling that American tanks could exploit the chaos before German defenses could solidify the armored exploitation. Began at dawn on July 26th, Combat Command A of the 2nd Armored Division, led by Brigadier General Maurice Rose, drove south from the Saint-Lô area with orders to advance as far and as fast as possible. Rose was an aggressive commander who understood armored warfare and knew how to exploit success. His column consisted of Sherman tanks, tank destroyers, armored infantry and half-tracks, and self-propelled artillery, and crucially, the majority of his tanks were equipped with Coulin's hedgerow cutting devices. For the first time since D-Day, American armor operated with true mobility and freedom of maneuver in the Norman bocage. The Rhino tanks crashed through hedger after hedgerow, choosing their own routes, avoiding German strongpoints, exploiting gaps in the disintegrated German defense tank commanders no longer needed to follow roads where German anti-tank guns might be positioned. They no longer needed to search for gaps in hedge that might be covered by German fire. They simply drove, cross-country breaching obstacles at will, maintaining momentum, preventing Germans from establishing new defensive positions. The psychological impact on German forces was catastrophic. For 6 weeks, German defenders had relied on the bocage as their primary defensive advantage. They had used the hedge to channel American attacks into predetermined killing zones. They had positioned anti-tank weapons to cover the few routes through which American armor could advance. Now, suddenly, impossibly, American tanks were appearing from unexpected directions, breaking through hedgerows that Germans had assumed were impossible barriers. The entire German defensive system, carefully constructed over weeks of combat, was rendered obsolete in a single day. German attempts at counterattack proved futile. Small groups of German infantry attempting to block American advances found themselves bypassed and isolated as American tanks drove through hedge on either side of their positions. German anti-tank guns, carefully positioned to cover roads and known passages, found their fields of fire blocked by hedgerows, while American tanks emerged from directions the Germans had not anticipated. German officers attempting to coordinate defense found themselves unable to predict where American armor would appear next. By midday on July 26th, lead elements of the 2nd Armored Division had advanced 6 kilometers beyond the start line, 6 miles in half a day. This was farther than the entire First Army had managed. To advance in the previous 2 weeks of grinding attritional combat, the contrast was stark and dramatic. The town of Marigny, a significant road junction 6 kilometers south of the start line, fell to the 1st Infantry Division, supported by the 3rd Armored Division. German prisoners, many of them reinforcements who had just arrived from training battalions in Germany, surrendered in such numbers that American units simply directed them to walk to the rear without guards. There were not enough military police to process them all. A senior non-commissioned officer in a German medical unit, identified in captured documents only by his last name, Kleene wrote in his diary on the evening of July 26th, "Today we understood that everything is lost, the Americans have broken through. Their tanks are everywhere. They come from directions we thought impossible. Our defensive positions that held for weeks are suddenly worthless. The men are talking among themselves in ways that would have been unthinkable a week ago. They speak of survival, not victory. They speak of escape, not defense. Morale has collapsed overnight. July 27th, the American advance accelerated. The 30th Infantry Division, which had suffered the worst of the friendly fire casualties on July 25th, reported in words that would become famous, "This thing has busted wide open." The 3rd Armored Division reached the area around Coutances, a critical road junction approximately 15 mi behind what had been the German front line just 2 days earlier. German forces attempting to withdraw south to avoid encirclement found their routes blocked by American armor that had already penetrated deep into their rear areas. Entire German units were cut off, surrounded, destroyed, or forced to surrender. The breakthrough achieved by July 28th exceeded even Bradley's optimistic projections. American forces had penetrated more than 20 Swordsmen beyond the start line in just 3 days. The German 7th Army, which had fought the Americans to a standstill for 6 weeks, in the bocage, was in full retreat. Its units scattered and disorganized, its command structure shattered, its ability to conduct coordinated defense destroyed. The bocage, the nightmare terrain that had seemed to make sustained offensive operations impossible, was now behind American lines. Ahead lay the relatively open country of central France, where American mobility and firepower advantages could be employed without restriction. Post-battle analysis conducted by American intelligence officers in the weeks following Operation Cobra revealed the decisive role of the Rhino tanks. Staff officers examined after-action reports, interviewed unit commanders, and compiled statistics on how hedgerows had been breached. During the offensive, the conclusion was clear and dramatic. Approximately 70% of successful hedgerow breaches during Operation Cobra were accomplished by tanks equipped with Culin's devices. The remaining 30% required engineer support with explosives, bulldozers, or manual labor, all of which were significantly slower and more vulnerable to German defensive fire. Tank crews reported that the culin devices allowed them to breach typical Norman hedge in less than 10 seconds from initial impact to emergence on the far side. This speed was absolutely critical to maintaining momentum and preventing German forces from repositioning to counter each breach. Previous methods of breaching hedgerows had required anywhere from 10 minutes to half an hour, allowing Germans to prepare defensive fire against any breach. The speed advantage provided by the Rhino tanks gave American forces the tactical surprise and tempo that made rapid exploitation possible. American tanks equipped with culin devices also suffered significantly fewer casualties than unmodified tanks operating in the same terrain. Ordnance officers analyzing loss rates found that Rhino tanks experienced approximately 40% fewer tank kills than standard tanks in bocage terrain. The primary reason was simple. Modified tanks did not expose their vulnerable belly armor when crossing hedgerows, eliminating the single most common cause of tank losses in the bocage German panzer teams that had devastated American armor. In June and early July, found their tactics suddenly ineffective against Rhino tanks that drove through hedge at ground level. The strategic impact of Operation Cobra was immediate, dramatic, and far-reaching. By July 31st, just 6 days after the offensive began, the 8th Corps had captured the town of Avranches, described by military historians as the gateway to Brittany and southern Normandy. The capture of Avranches opened routes south into Brittany and east toward central France, the entire Normandy. front, which had been static for 6 weeks, suddenly collapsed. German forces that had fought so effectively in defensive positions found themselves unable to conduct mobile defense in open terrain against American armor that could now maneuver freely. American forces poured through the gap at Avranches like water through a broken dam. On August 1, 1944, the 3rd United States Army was officially activated under the command of Lieutenant General George Smith Patton, Jr. Patton was one of the most aggressive and controversial American commanders, a man who understood armored warfare and believed in rapid exploitation and deep penetration. Third Army's mission was to exploit the breakthrough achieved by First Army racing south into Brittany, to capture the ports, and east toward the Seine River, to encircle German forces still fighting in Normandy. Patton's Third Army advanced with a speed that astonished both American and German commanders. Armored columns raced across France sometimes, covering 50 emirat in a single day, bypassing German strongpoints, leaving isolated German units to be quickly mopped up by following infantry. The grueling war of attrition that had characterized Normandy from D-Day to late July was replaced almost overnight by a dynamic war of maneuver where American advantages in mobility, logistics, and overwhelming air power could be fully exploited. The liberation of Paris followed on August 25th, just 1 month after the launch of Operation Cobra. General Charles de Gaulle personally led French forces into the city as German. Resistance completely collapsed. The encirclement and systematic destruction of German forces in the Falaise pocket, completed in mid-August, trapped between 50,000 and 100,000 German soldiers, effectively destroyed the combat effectiveness of entire divisions. Tanks, artillery, and vehicles that managed to escape the pocket itself were relentlessly destroyed by Allied fighter bombers as they retreated toward the Seine. The Wehrmacht in France never recovered from this catastrophic defeat. For Curtis Culin, recognition came in the form of prestigious military awards and media attention, though both were somewhat bittersweet. General Omar Bradley personally recommended Culin for the Legion of Merit, a decoration typically reserved for officers who had distinguished themselves through exceptionally meritorious conduct in the performance of outstanding services. The citation accompanying the award praised Culin's inventive contribution to the success of Operation Cobra and noted that his device had saved countless American lives by restoring crucial tactical mobility to armored forces at a pivotal moment in the campaign. Newspapers across the United States picked up the story, transforming Culin into a minor celebrity almost overnight. The Cranford Citizen and Chronicle, his hometown newspaper, published a feature article on September 7, 1944, highlighting how a local sergeant had invented a device that revolutionized warfare in Normandy and contributed decisively to the Allied breakthrough. The article included interviews with Culin's parents, who still resided in Cranford, and detailed his pre-war life as an ordinary young man working in the liquor industry. The story perfectly fit the American narrative of citizen soldiers using practical ingenuity to overcome obstacles that had stumped even trained experts. But Curtis Culin himself, demonstrating the characteristic modesty that defined him throughout his life.